We're going to start this chapter by talking about scatter plots. Scatter plots are graphs used to study the relationship between two quantitative variables. The two different variables that we're going to talk about are explanatory variables and response variables. Explanatory variables are the same thing as like the x variable, and then your response variable is the same thing as your y variable. Whenever you are asked to describe a scatter plot, which will happen often, you need to make sure that you describe the direction, the form, and the strength. The direction can be described as either positive or negative, so positive or negative. The form is linear or nonlinear, so something that's nonlinear can be described as curved, exponential, or quadratic, but mostly in this chapter we're going to be talking about linear scatter plots. And then we also need to talk about the strength, and then the strength can be discussed as weak, moderate, or strong. So in this example, you can see a graph that shows comparing people's height and hand span. The x variable is hand span, which should affect the response variable, which is height, or the y variable. Whenever it comes to describing this, you can see the description here. It says there is a moderately strong positive linear relationship between height and hand span. So if we break this down, you see that we have talked about the strength, so moderately strong. We've talked about the direction, which was positive, because as hand span increases, height is increasing as well. And then we also talked about the form. It's saying that there's a linear relationship. And then the last here we have between height and hand span, we actually used context. Always use context whenever you are describing a scatter plot. So with scatter plots and comparing to quantitative variables, you'll be able to measure strength and variation. The first thing we're going to talk about is correlation coefficient. Your correlation coefficient is represented by the variable r, and what that does is it measures your strength and direction of two different variables. So you can see on here we have a scale from 1 to -1 of R of 1 represents a perfect positive correlation, and then a R value of -1 represents a perfect negative correlation, and then everything in between can be seen on this representation. So then we have something called a coefficient of determination, which is R squared. So it's just the correlation coefficient squared. And your coefficient of determination cannot tell you a direction, but it does measure how much variation there is between your regression line, so between that regression line and all of the data points around it. In addition to just being able to find your R squared, you're going to need to be able to interpret them. To interpret your correlation coefficient, or your R, you can look at the sentence stem here. It says there is a moderately strong positive association between x and y. Now in this example, I used moderately strong positive, and that could change. It may be a weak negative association or a weak positive association, but whenever you see that x and that y, you need to make sure that you put your x and your y in context. So using the example that we had before, there is a moderately strong positive association between hand span and height. And then for the coefficient of determination, or your R squared, you're going to say blank percent of the variation in y can be explained by the linear relationship between x and y. That blank percent, whenever you have your R squared, let's say it's 0.68, you're going to make sure that you change that to a percentage, and you would say 68% of the variation in height can be explained by the linear relationship between hand span and height. So make sure that you always plug in that x and y with context, and make sure that whenever possible you use units as well. So the least squares regression line should look pretty familiar, especially whenever you look at the formula, but it is just used to predict how your response variable y changes as your x changes. The equation is y hat equals b plus ax. Should look kind of like y equals mx plus b, because it is pretty much the same thing, but we need to make sure that we switch the y-intercept and the slope. Also, that y hat that you see there, that stands for the predicted y, because we don't know exactly what the y is going to be. The least squares regression line is just used to predict what y is going to be based on what the x is. And then your b, again, that's your y-intercept, your a is your slope, and then your x is your explanatory variable. For interpreting the slope and the y-intercept, it's a good idea to just have these prompts memorized, but it really helps if you understand what slope and y-intercept are. So if you think back to just Algebra 1, when we first learned about slope and y-intercept, it's really helpful. For the slope, A, you are going to say as x increases by 1 unit, the predicted y increases or decreases by a unit. So increases or decreases by whatever the slope is. You need to make sure that you use context and then also specify the units. So let's use the example that we had with height and handspan. So for the height and handspan example that we had earlier, we would say as your handspan increases by 1 centimeter, the predicted height increases by 10 centimeters. For the y-intercept, you're going to make sure that you remember, okay, y-intercept is what y is when x is 0. So if you're interpreting the b, you're going to say when your x is 0, the predicted value of the y hat is blank, so whatever the y-intercept is. To put context to this one, we'll use height and handspan again. When handspan is 0 centimeters, the predicted value of the height is 140 centimeters. Now, that doesn't necessarily make sense because whenever you have a handspan of 0, you don't expect for a height to be 140 centimeters. It doesn't have a meaningful interpretation, which is totally fine as long as you understand how to interpret it and then know whether or not it's meaningful. So a term that may be new to you is residuals. Residuals are just the difference between your observed value, so the actual data points, and then whatever our least squares regression line predicts. So if you look, the formula for residual is y minus y hat, so that's actual minus predicted. Your residual is the distance from the line to each data point. So if you're looking at this graph comparing people's height and handspan, that line is your least squares regression line. And then each of those little x's are your actual data points. So the residual would be, if you look at one of those x's, let's look at the one at the very top left, the residual is the distance between that x, or that data point, and the actual trend line or the actual least squares regression line. Any data point that is above the line is a positive residual, and it means that your formula or your least squares regression line actually underestimated. And then any data point that is below the trend line is a negative residual, and it means that your prediction line overestimated. For this example, it says the least squares regression equation used to predict someone's height based on handspan is y hat equals 140 plus 3.33x, where y is your height and x is your handspan. Calculate the residual for someone who has a handspan of 18 centimeters and a height of 140. So remember to calculate the residual. So we've got residual equals y minus y hat, or actual minus predicted, and we do have the actual because it says someone has a handspan of 18 and a height of 140. So what it's giving us there is it's giving us a coordinate. It's giving us an actual data point with an x of 18 and a y of 140. So what we need to do is we need to use this formula to find the residual. Actual minus predicted, the actual y. So we are going to find the residual by doing the actual y, 140, minus the predicted. Now we need to find the predicted. Well, we have the prediction line, so to find the predicted, you just have to plug in the x, and that's going to give us what our equation would predict. So we're going to do 140 plus 3.33 times 18, and that is going to give us our y hat. All right, so if you type that in the calculator, 140 plus 3.33 times 18, you should get a prediction of 199.94. So that's what it's predicting. Now to find the residual, we are going to take the actual 140 and subtract our predicted. So 140 minus 199.94 is going to give us a negative 59.94. Right? A negative 59.94. And then what this means is that our residual, yes, it's a negative 59.94. A negative residual means that our least squares regression equation actually over-predicted, so this is what they predicted, they actually over-predicted the hand span for someone who, they over-predicted the height for someone who has a hand span of 140 by 59.94 centimeters.